Hello learners, today we are going to talk about rocks, but not all rocks, a special category of rocks known as metamorphic rocks. And what we will discuss is that how do we study these rocks, and we will see that there is only one single approach which allows us to tackle and study these rocks. So, we will be looking at the metamorphic rocks, which constitute one category of rock along with the sedimentary and igneous rocks, and we will see that we can only study them as chemical systems to work out the true geological history of any terrain. It will be interesting first to discuss and to understand the definition of metamorphism. Metamorphism is a process which involves changes in the mineral content, composition or microstructures of a rock, and this happens dominantly in the solid solution. Now, this process occurs due to an adjustment of the rock to physical conditions that differ originally formed conditions, and that also differ from the physical conditions which normally occur on the surface of the earth and slightly below in the zone of diagenesis. This process may also coexist with partial melting and may also involve changes in bulk chemical composition of the rock. In order to understand this, let us look at this beautiful image of a deformed rock. Now, in this rock, the rock is transformed, which means that there was earlier another rock and that rock got transformed. Now, that rock could have been a sedimentary rock or an igneous rock. This particular case, it was a sedimentary rock. Since it was a sedimentary rock, which is normally called as a layered rock, it had different layers. When it got transformed, those different layers produced new set of minerals. If we see in this, you see there are two kinds of layers, one which are white and black and the other which are brownish. Both have different mineral content and composition, but both have undergone same metamorphism. So, the problem is how do we study a rock which has transformed into two different results, but which has undergone the same process. If we look at another example of a similar rock which was earlier a metamorphic rock. Now, you see in this there is the portion here where some minerals occur. These minerals are a metamorphic mineral and are known as staurolite. These minerals got transformed into garnet. What you see garnet, these minerals are garnet. Now, this transformation occurred and the garnet represents now the latest metamorphic rock, and this staurolite represents mineral of a pre-existing rock which got metamorphosed or transformed. So, therefore, both minerals do not constitute one particular mineral of a rock and they need to be distinguished. They cannot be distinguished in the conventional sense of a normal study of a rock. Again, let us see in which way we look at other rocks. If we look at igneous rocks, we classify them either on the basis of their mineral composition or on the basis of mineral proportion or on the basis of the sizes of the grains. Let us, for example, fine grained rocks we call as volcanic and coarse grained rocks normally we call as plutonic. Similarly, when we study sedimentary rocks, We also discuss on similar criteria, that is fine grained clastic rocks we call as shale, coarse grained rocks we call as sandstone, conglomerate, etc. We also distinguish this on basis of mineral content, like calcite bearing rocks we call as limestone and similarly other rocks. However, we cannot apply these criteria to metamorphic rocks as we saw earlier, because neither the amount of mineral nor the size tells us about the metamorphic transformation, and each metamorphic rock is characterized by a set of minerals which is called as mineral assemblage. So, this necessitates a new approach or a different approach which is applied to igneous and sedimentary rock for the metamorphic rocks. One of the way to overcome this problem is to think of metamorphic rocks in terms of chemical systems. Now, the chemical systems are in terms of chemistry of rock. So, which means that each rock represents one particular chemical system. In nature, most of the processes tend to move towards states of minimum energy. If we try to define a system, the system is any part of universe in which we may be interested at a particular point of time. Since we are discussing metamorphic rocks, so each metamorphic rock becomes a system. We will also see that it is not even that simple. The layers of different composition may themselves behave as separate systems within a metamorphic rock also. Now, when a system undergoes transformations, because of energy acting on it, there two kinds of systems can be there. One, where the material or mass of the system interacts with the surrounding, that is, the mass gets transferred out and in to the system. Those kind of systems are called as open systems, or only energy can be interactive, that is, either energy is lost or energy is gained by the system, in our case represented by a metamorphic rock, and those kind of systems are closed systems. There are also another kind of systems where neither energy nor mass is transferred, they are called as isolated systems, but they are not important for our discussion of metamorphic rocks. If you recall the definition of metamorphism which we discussed just a few minutes ago, these transformations normally occur in solid state. So, therefore, in solid state transfer of mass is not easy. So, most of the metamorphic rock represent a closed system, that is where mass is retained, mass does not get transformed or transferred, and only the energy changes. All natural systems try to go or move towards steady state. This is one concept which is important in geology and in nature. Steady state means that there can be change in property with respect to space, but there will not be any change with respect to time. For example, there is something which is called as geothermal gradient, that is variation of temperature as you go down in earth. So, the variation in temperature, if it does not changes with time, will be that there is a temperature on surface and a temperature increases, let us say 30 degree centigrade per kilometer as we move down. If this does not changes with time, it is a steady state geothermal gradient. So, most of the natural processes tend to be steady state, that is a metamorphic rock will try to reach a situation where it does not changes with time, and that is achieved by the mineral assemblages achieving some sort of equilibrium within themselves. We can now look back at what we have learned. We have learned that the metamorphic rocks cannot be studied in similar fashion as sedimentary and igneous rocks, essentially because they represent transformed sedimentary, igneous and earlier metamorphic rocks. The criteria or the handle or the tool can be considering them as chemical systems. The chemical system approach requires a rule which defines these changes, and that rule is the Gibbs phase rule.